Hello, hello. Today we're going to move on. You're going to talk about Lesson 16, which is Algebraic Expressions. We worked with numeric expressions, which were all numbers. You follow order of operations to solve. Now we're going to throw in some variables, which are the letters. So we're going to work with algebraic expressions. So, use what you know to describe the expression 2x plus 5 in words. A says, what does the letter X stand for? So, at this point, X is just representing a number, right? Do we know what that number is? Right now, we don't. So we would say that it represents an unknown number. It could be any number out there. B says, which operation is represented by 2x? Now, we talked about this the other day when we were going through PEMDAS. I said that sometimes you will have a number or two letters side by side. When they are side by side, the 2 is right next to the x. It means that you are going to multiply. So it's multiplication. C, what do you call the result of this operation? Well, what's the answer to a multiplication problem? It is the product. D says, what operation does the plus sign show? Well, obviously that's addition. E, what do you call the result of this operation? The answer to an addition problem is called the sum. Extra loop there. Let's try that again. And then F, explain what the whole expression represents. It represents multiplying 2 by a number, then adding 5. Or you could say the sum of 2 times a number and 5. Either one of those would work to show what the whole expression represents. Alright, so let's find out some more. It says you have evaluated expressions with known numbers and operation signs. An example of this would be 6 minus 7 times 4. So that's what we were working on this week. Now you evaluate expressions that include variables. Remember, a variable is a letter that stands for an unknown number. Okay, you guys worked on vocab yesterday, so these should be familiar. So let's look at this expression. We had 2x plus 5. Every expression is made up of terms. A term is a known number, a variable, or the product of a known number and variable. Okay, so in this expression, we have two terms. 2x would be an expression because that's multiplying a number and a variable, and then 5 would be a term. A term that is known number without variables is called a constant. So a constant is your known number. It is the one that does not have a variable. So in the expression 2x plus 5, which one's the number? Which one is constant? It will not change. It will always be that number. It is 5. A term that includes variables is called a variable term. Obviously, it's a term. It has a variable, so it's a variable term. So in the expression 2x plus 5, 2x, because it's a variable and a number, which includes a term, which is a term, it would be 2x. If one factor of a variable term is a known number, that number is called the coefficient. Okay, so whenever you have a variable term, meaning you have a number and a variable, the coefficient is the number that is connected to the variable. So in 2x plus 5, 2x would be our variable term. The coefficient would be the 2 because it is the number connected to the variable. So look again at the term 2x. It means multiply a number by 2. You have used the symbol x for multiplication. However, now that you are using the variable x, you will need another way to show multiplication. The expression 2 times x would look confusing because it looks like 2 x's. So now is the point where we're going to start writing either the dot to show multiplication, or we're going to start writing numbers and variables next to each other. So either 2x, or you could do xy, and those would show that it is multiplication. So from now on, no more using this to write multiplication. We've got to start changing that to either the multiplication dot or writing things side by side like this. Okay? So let's reflect on this. It says, Claire says the expression 8x cubed has 3 terms, 8, x, and 3. Is she correct? And explain. So if you look back up at the top, a term is a known number, a variable, or the product of a known number and variable. So would that be 3 terms? Would we take this right here and separate that all individually into the numbers and the variables? No, we would not. 8x cubed is 1 term because it includes a known number, x cubed, which is a product, so it would be 1 term. Okay, so now we're going to continue on and we're going to talk about how we can write these variables and these expressions. So it says, write an expression with the same meaning as subtract a number times 4 from 10. So 2 different ways we can look at it for the model it. You can look for the operation words to help you write the expression. So it says subtract a number times 4 from 10. So we know if it says subtract, that we're going to be subtracting. So you can see that they put the subtraction sign here. And we know that we're going to be, since we're subtracting, we have to have 2 terms. So it will have first term minus the second term. The second model it shows that you can think of similar expressions to help you write the expression. So if it says subtract 6 from 10, we know that we're going to do 10 minus 6. If it said subtract a number from 10, we don't know what that number is, so we can put in a variable, which would be x, and we take that away from 10. If it says a number times 4, we know that we'd use our variable and we'd multiply it times 4. So you can see they have 4x because side by side means to multiply. So if we put these all together, and it says subtract a number times 4, which is just like this, we would write it as 4x. Okay? And then it says subtract it from 10. So that would be like this. So we would put 10 minus 4x. So now that we know this, let's move on and answer some questions about it. Number 2 says, look at the first model in the previous page. When you subtract a number from 10, will 10 be the first or the second term? Well, we just talked about this. If we're subtracting from 10, 10 will be the first term because we have to take from it. So it has to go first so that we can take away from it. 3. Erica says that the expression 4x has one term. Is she correct? Is it a known number? Is it the product of a known number and a variable? Or is it a variable? Yes, it is one of those. So yes, 4x is a term. And it's a product of a number, known number, let's add that in, and variable. Okay, number 4 says, look at the second model it. Write an expression for subtract a number times 4 from 10. Well, we did that on the other page. So if it says subtract a number times 4, so that would be subtracting our 4x, and we're taking it from 10, so we put the 10 first. So we get 10 minus 4x. Number 5, list each term in your answer to problem 4. So we're doing each term. Well, we have a known number, that's our constant, and then we have our known number times a variable, that is our coefficient with a variable. Number 6 says, does your answer to problem 4 have any constants? Do we have any terms in here that are a number that will not change? Yes, we do. It is 10 because it does not change. Ten will always be 10. Number 7, what are the coefficients, if any, in your answer to problem 4? Explain. Well, we have 10 and we have 4x. We know 10 is our constants because it's always going to be 10. It doesn't change. But we have a 4x. A coefficient is a number that is connected to a variable. So if we have 4x, we have a number connected to a variable. So yes, we have a coefficient because it is a known number and variable. Number 8, explain the difference between a constant and a coefficient. A constant is just a known number. And the coefficient is a known number with a variable. So the constant is just the number, the coefficient is the number with the variable. So now you try it. Use what we just talked about up above to answer 9, 10, and 11. Pause the video, take a couple moments, and answer it, and then you can start it to check your answers. Okay, number 9 says, write an expression with the same meaning as the result of multiplying 1/2 by a number. So 1/2 by a number, which we don't know, so we use a variable. Then subtracting 9. So after we multiply, then we subtract 9, so it would be 1/2 x minus 9. 10, write an expression with the same meaning as 7 less than the square of a number. So we don't know what number, so we use x, and if we're talking about a square, remember we're exponent, it would be x squared, and it's 7 less than that. Well, if it's 7 less, we have to take away 7 from the x squared. 11, write an expression to represent the sum, remember that's addition, of 3 and the quotient of a number divided by 6. So when it says quotient, that is the answer to a division problem. So if it's a number, we use x, and we're dividing it by 6. So it would be 3 plus x divided by 6. Alright, so now we're going to write and evaluate them. Jennifer buys 1 pack of orange sugarless gum and 3 packs of mint sugarless gum. The pack of orange gum has 8 pieces. The pack of mint gum each have the same number of pieces. Write an expression to show the total number of pieces of gum that Jennifer buys. If 1 pack of mint gum has 6 pieces, what is the total number of pieces of gum that Jennifer buys? So we have 2 questions here. The first one says picture it. You can draw a picture to help you understand the problem. You can draw the packs of gum and label the number of pieces in each pack. So we know that there are 8 pieces of orange gum. Okay, so you can see they have orange and they put 8. And then 3 packs of mint gum, but we don't know the number of pieces. So if you notice, they put P for the number of pieces because it's our unknown number. So how many P packs of gum do we have? Well, we have 3 with P number of pieces in them. So we would multiply to find that answer, right? But then we also want the total number, so we would be adding the orange gum, which is how many pieces? It's 8. So we would write 3P plus 8. The second model says we can use words to help us. It says you can write a sentence describing the total number of gum pieces. So obviously we're adding because we said the total number. And it's the sum of how many in the orange gum and how many pieces in the 3 packs of mint gum. So the word sum tells us that we're going to have to add for our overall shape. So just like up above, we have the 3 packs of some number of pieces for the mint gum plus the 8 pieces for the orange gum. So let's go through some of the questions. Now you will solve the problem from the previous page. Number 12 says, write an expression for the number of pieces in 1 pack of orange gum. So we're just focusing on the orange gum. How many pieces were there? Well, there were 8. So that would be our expression, just 8. It is what kind of a number? It is a constant because that 8's not going to change. It's going to stay the 8. 13. Write an expression for the number of pieces in 3 packs of mint gum. Well, we have 3 packs. We don't know how many pieces, so we used the variable P, and we know we'd multiply those, so I put them side by side. So this term is a variable term. Just throwing in those words in there so that you start getting used to them. The 3 is the coefficient, and then the P is your variable. Got to get used to those terms. We're going to start using them a lot. 14, write an expression for the sum of the number of pieces of gum in 1 pack of orange gum and the number of pieces in 3 packs of mint gum. Well, we already know how much for the orange. We already know how many for the 3 packs of mint. Now we just do the sum. So it would be 8 plus 3P. Now if you notice, this looks a little different than the one we did on the previous page. I wrote this. Does that change anything? When we are adding, does it matter what order we put the terms in? No, it doesn't. So either one of these would work. 15, explain how you could use the expression from problem 14 to find the total number of pieces Jennifer buys if each pack of mint gum has 6 pieces. Well, if I have 8 plus 3P, and I know that the pieces in the mint gum is 6, I can take and replace the P with the number. So I would do 8 plus 3, and then I'm going to put a parentheses because when you have 2 numbers side by side, they look like it's just a whole number. So if you put it in parentheses, it means that you're multiplying them. And I replace that P with a 6. So now I can follow my order of operations and I can solve this problem. I would multiply first. 3 times 6 is 18. Bring down the rest, and 18 plus 8 would give me a total . 26 is correct. So take a couple seconds, pause the video, work out 16, 17, and 18. When you're done, you can go ahead and resume the video to check your answers. Okay, so here we have our answers. On the first one, you would have 2x minus 3, and when you work that out, you would end up with 53 inches. On the second one, Tracy has 5 cans, 4 of them have 6 ounces, so that's where the 4 times 6 is. And then you have to add that last can for your C. Well, if we go ahead and simplify and do 4 times 6, we'd get 24 plus C. Then we know that the 12 ounces is how much the last can is, so you would add 24 plus 12 to get 36. On the last one, Brian did 8n plus 2 and got 83 when n equaled 1. Well, if we use n equals 1, you would multiply 8 times 1, which is 8, and then you would add 2 and get 10. When he did 8 times 1, he did not write it in parentheses, and it made it look like 81, so he did 81 plus 2, which is where he got his 83. Make sure when you're multiplying these numbers, you put it in parentheses, because if not, it looks like a whole number. Okay, writing and evaluating expressions. Last year, the Speedster Bicycle Company held a bicycle design contest and awarded a cash prize. This year's the contest prize is $20 less than 3 times last year's prize. Evan and Gina win this year's contest and split the prize money evenly between them. Write an expression to show how much prize money Evan wins. If last year's prize was $50, how much prize money does Evan win? So 2 questions here once again. So our picture, it says you can draw a picture to help understand the problems. You can represent the prize money as envelopes and draw a line to show Evan's half. So you can see last year's prize is here, and then this year's prize is 3 times that. So it would be 3 of those envelopes minus the 20, because it's 20 less than 3 times. Okay, so you can see then they have to split it in half. Okay, so you can model it using words. It says the contest prize is 20 less than 3 times last year's. So once again, you know you're subtracting. Evan gets half the prize, so once we subtract, we divide by 2 because that's how you get half. Let's answer some questions. Look at the model it on the previous page. This year's prize is 20 less than another amount. Will 20 be the first amount or the second amount? And then explain. Well, if we're talking 20 less than something, it has to be the second amount. Because it is less than the previous amount. Okay, 20 says explain how to write an expression for 3 times last year's prize. Well, if we let X be last year's prize, we would do 3 times that amount. So it would be 3X. Write an expression for 20 less than 3 times that amount. Last year's prize. So 3X is last year's prize. If we're talking less than, it would be subtracting 20. Chandler writes the expression 1/2 times 3X minus 20 to represent Evan's winnings. Is she correct? Explain. Well, if we divide by 2, isn't that the same thing as multiplying by 1/2? Yes, it is. Because multiply by 1/2 is the same as dividing by 2. Explain how you can find how much money Evan wins if last year's prize was $50. So we would need to take our expression, and if we know that X is last year's prize. That's supposed to be an X. We just place that $50 in. So we would do 3 times last year's prize, which is 50, and then minus 20. So now I can go through and solve it. 3 times 50, because multiplication comes first, is 150. Bring down the minus 20. 150 minus 20 is $130. Now I have to take all this and multiply it by 1/2 or divide it by 2. So when I do that, I would get a total of $65 each. Now you try. Take a couple moments, pause the video, work it out. When you hit play again, it will give you answers. All right, so here we go. 24, it says the price of 1 share of XYZ stock drops by 2 cents on Monday, and on Tuesday the price goes back up to 5 cents. Write an expression with 3 terms to show the change of price in XYZ stock. Well, we don't know the price, so I'm going to use P for the price of stock, and that's what I start with is P. Well, if it's dropping, we're taking 2 cents away. And then on Tuesday, it goes back up, which means we're adding 5 cents. So it would be P minus 2C plus 5C. You can use X, you can use whatever variable you want. It does not have to be P. Now it says, on the second part, if 1 share of XYZ stock costs $34.18 at the start of business on Monday, what is the price when it closes on Tuesday? Well, basically they're telling us that P is $34.18, or whatever variable you used is $34.18, excuse me. So you plug it in. So I put $34.18 minus 2 cents plus 5 cents. Work left to right because I have both addition and subtraction. So I do $34.18 minus 2 cents to get $34.16. Then I bring down my plus 5. Then I add $34.16 plus 5 cents to get a total at the end of the day on Tuesday of $34.21. Stop now. Go ahead and get on the Chromebook, or go ahead and open up Classroom and go back to the exit ticket and complete the exit ticket.